Python decorators, they can feel a bit like magic, right? With just a single line, you can sprinkle in new functionality to code you've already written. But that magic, well, it's a double-edged sword. It can lead to some beautifully clean code or a really confusing, hard-to-debug mess. So how do we get all that power without the pitfalls? Let's dive in and figure it out. Okay, so we've all been there. You're building something and you realize, hey, I need to add logging here. Or maybe you need to check user permissions, or even just time how long a function takes to run. And before you know it, you're copying and pasting that same chunk of setup and teardown code into every single function. It just clutters up your core logic, and honestly, it becomes a total nightmare to maintain. That's what I call the everywhere code problem. Now, these features have a fancy name: cross-cutting concerns. Just think of them as behaviors that need to slice horizontally across many different, totally unrelated parts of your code. Logging isn't really part of a single function's main job, but it's something you need to apply all over the place. And figuring out how to handle that cleanly, that's a classic software design challenge. Just take a look at this. On the left, we've got our core logic literally sandwiched between logging calls. This is that cluttered approach. I mean, it works, sure, but it's noisy, and it kind of breaks the whole idea that a function should do one thing well. Now, look at the right. This is what we're aiming for. Our function is clean, it's focused, and that one little line, the @log_execution decorator, adds all the logging behavior we need without ever touching the function's insides. That's the power. Now, before we get to Python's really elegant way of doing this, it helps to know where the idea came from. The traditional way to solve this problem is with a classic object-oriented decorator design pattern. It involves creating a whole series of classes that wrap around each other, but as you're about to see, for Python, it's often, well, it's a bit much. So with the classic pattern, you have to create a base component, and then you manually build this chain of wrapper objects. You pass your component into a logging decorator, then you take that whole thing and pass it into a benchmark decorator. It's kind of like those Russian nesting dolls, but with code. It's powerful for sure, but man, is it verbose. You end up with a lot of boilerplate classes just to get it working. Luckily for us, Python gives us a much cleaner way to do this. And the reason is actually pretty simple. In Python, functions are what we call first-class citizens. All that really means is you can treat a function like any other variable. You can pass it to another function, you can return it from a function, you can just toss it around. And that one simple feature completely flips that clunky class structure on its head. So here's the big secret. A Python decorator isn't some crazy magical thing built deep into the language. At its heart, it's just a normal function that follows a pattern. It's a function that takes another function as its input, defines a new wrapper function inside itself to add the extra behavior, and then it just returns that new, shiny, enhanced wrapper function. That's really it. This line right here, this is the whole trick. When you apply a decorator, what Python is really doing behind the scenes is this. It takes your original function, in this case, count primes. It passes it into the decorator function, benchmark, and then it reassigns the name count primes to whatever new function the decorator hands back. It's just a simple reassignment. So yeah, that manual reassignment we just looked at, that is the decorator. Everything else is just a shortcut to make it look a whole lot nicer. And this is the shortcut. That little @ symbol is what we call syntactic sugar. It does the exact same thing as that reassignment, but it's just so much cleaner, so much more declarative. You just sprinkle the decorator on top, and it clearly says, hey, I'm enhancing this function with some new behavior. All right, so decorators are powerful. They're clean. It's really tempting to start plastering them all over your code. But hold on. This is where a bit of senior engineer wisdom comes in. If you want to avoid creating a confusing mess for your teammates, or even for your future self, there are two critical rules you have to follow when you write your own. Okay, here's the first trap people fall into. You write this awesome decorator, you use it, and then you go to check your logs, or maybe you hit a breakpoint in a debugger. And instead of seeing the name of your original function, count primes, you just see wrapper. You're left thinking, wait, what's wrapper? Where did my function name go? It can make debugging a real pain. And that brings us to rule number 1. You have to preserve the function's identity. Your decorated function needs to keep its original name, its docstring, all of its metadata. This is absolutely crucial for tools like debuggers and even Python's built-in help function to work properly. And guess what? The fix is incredibly simple. Python's standard library has our back. Inside your decorator, you just apply another decorator, @functools.wraps, to your inner wrapper function. You pass it the original function, and it's like a little copy-paste machine. It automatically copies all the important stuff, like the name and the docstring, over to your wrapper. And just like that, your decorated function starts playing nice with all your tools. Okay, rule number 2, and honestly, this one is even more important for writing code that your teammates won't secretly hate you for. A decorator should never change the arguments a function accepts or the type of value it returns. Ever. This quote right here just nails it. If your function signature says it takes 2 arguments, but your decorator secretly messes with them, you've just broken the contract of that function. If it's supposed to return a number, but the decorator makes it return a string, well, your type checkers are going to scream, and your teammates are going to get really confusing errors. A decorator should enhance, not alter, a function's core job. So with these rules in mind, when should we actually reach for a decorator? The answer is only when it's the simplest and clearest tool for the job. And believe me, they are not always the best solution. This table gives us a really good way to think about it. For those low-level generic things like logging or caching, stuff you want to apply all over the place, decorators are a great fit. Their goal is to add behavior to a function. But for your high-level business logic, like calculating a report or processing an order, simple function calls are almost always better. Their goal is to compose behavior with other functions. The big difference is readability. Simple functions are explicit, while decorators can sometimes hide what's really going on. And that's the key takeaway here. Decorators can look super elegant, but they hide the flow of execution. Sometimes, the most readable, the most testable, and the most maintainable code is the boring code, where you can clearly see that function A calls function B, which then calls function C. You know, simplicity beats cleverness every single time. So the next time you're about to reach for that @ symbol, just pause for a second and ask yourself this question. Is this decorator actually making my code clearer, or is it just making it more clever? Am I solving a real cross-cutting concern, or am I just adding a layer of magic that's going to confuse my future self and my team? The answer to that question will guide you toward not just code that works, but code that's truly maintainable and elegant.